Welcome back, campers. We're going to skip section 1.3 and go straight to 1.4. So we're going to be looking at circles. All right, so the definition for a circle, it's the set of points in the xy plane, so the graph, that is a fixed distance r, or the radius, from the point h comma k. So again, the r is the radius, and then that point hk is the center. So equations for circles can be written in two different ways. There's standard form, which would be x minus h squared plus y minus k squared is equal to r squared. And we like this form a lot because we're able to get the center and also the radius straight from this equation without having to really do any math. So the center comes from whatever makes each of these parentheses equal to 0, which would be h and k. And then the radius is from the other side. Just take whatever number is over here and square root it and simplify it as much as you can. So the square root of r squared is going to be r. It's not always going to be a whole number. It can be a fraction. It could still have a radical in it. So like if this number was a 5, if you square rooted 5, you just get root 5, and that's all you can do with it. So don't panic if your radius is a weird number. That's okay. It just means you've got a weird number. So pre-calculus that means the numbers are going to get weirder and weirder, because in calculus, pretty much anything is fair game except for the complex or the imaginary numbers. So they don't have to be as nice. All right, now general form is where they've taken the standard and they've expanded it out. So they've squared this quantity, and ended up with x squared plus y squared plus ax plus by plus c is equal to 0. So they've expanded it out and they've moved whatever number was over here over to the left and set it to 0. Okay, so let's see how to kind of use it. So example 1, find the center and the radius of the circle, and then write the standard form of the equation. So here's our center at 1, 2, and the radius, which connects from the center to that point, well, that's got a distance of 2, so the radius is 4. So I can just stick everything straight into the standard form and be done with it. So x minus 1 squared plus y minus 2 squared is equal to, now my radius is 2, so when I go backwards, when I put it into the equation, I got to take that number and square it to give me a 4. All right, so example 2, for each of the circles, find the center, radius, and any intercepts, then graph the circle. Okay, dokie. Okay, so now you notice that this is not in standard form, so that's kind of a bummer. If it was in standard form, then we can get the center and the radius and draw everything, but it's not. So we're gonna have to take this and get it to standard form. So the first thing we want to do is we do not want any coefficients in front of the x squared or the y squared. So if there are any, we want to divide it out. So we're going to divide everything by 4. And then keep going. So it's like, well, professor, now what do we do? Well, we're trying to get this to look something like that. So we got to pretty much take the x's and factor them into a square, and also do the same thing with the y's. So we're going to do something, or use something that you you might have seen in Algebra 1. You definitely saw it in Algebra 2, or Math 120 if you took it at Folsom. And we're going to complete the square with the x's and also the y's. So let's group the x's together. And at the same time, I'm going to put in a blank. And my job, or my goal, is to figure out what number goes in the blanks so I can complete the square. So rearrange your x's together and your y's together, put a blank on each one. If there's a constant like this, the 1, we're just going to swing it over to the other side. And don't freak out if it's a negative number, don't worry about it. Okay, now you stuck 2 blanks over on the left side, so that means you have to put in 2 blanks over on the right. Because you have to do the same exact thing to both sides of the equation. Okay, so to complete the square, you take the number in front of the x term, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. If I square that, I get 1. So that goes in each of those blanks, one on the left, one on the right. Now if you look at the y's, it's the same exact number, so you should get the same exact result. So x minus 1 squared plus y minus 1 squared, because now you've completed the square, so you can factor it straight into the squares. And on the right side, just add everything up. So it comes out as 1. So our center is at 1, 1. The radius, the square root of 1, is always 1. So now I can go ahead and graph it. And I apologize for this. I keep forgetting when I make these notes. I will try not to do this on an exam or quiz, but the scale is a little bit different. I tricked myself when I was even doing my own notes. Every hash mark is a half, not 1. So 1, the 0.11 is actually right here. And then for the radius, when you go to draw your circle, just do a radius up, down, left, and right. And then just connect those 4 points with a circle. If it's a little bit lopsided, that's okay. Just, do your best. Okay. So that's it for that. We ended up with 2 intercepts, one on the y, one on the x. There you go. All right, for part B, same thing. We're going to need to complete the squares. So again, let's rearrange stuff. We'll swing that negative half over to the right. We'll put in our blanks. And we have to complete the square again. Well, the process never changes, even though the numbers do. So the number in front of the x and also the y, it's not always going to be the same. Just in these 2 examples it was. But you got to take whatever that number is, divide it by 2, and square it, even if it doesn't simplify. So 1 divided by 2 is 1/2. If you square that, you end up with a 4th. And same thing on the y's. Okay, so now it's going to factor. And when you factor it, if you look at this number and divide it by 2, whatever the result is, that's what it factors into. So 1/2 is just a half, so it's x plus a half. And yes, that trick always works. Just remember to include the sign if it's a negative. So if that was a minus, that would be a minus. So they're always the same sign. Same thing for the y. It's 1 divided by 2 is a half. So y plus a half. And then combine everything, so you get a 1. So the center is at negative 1/2, negative a half, and the radius is going to be a 1. Okay, so negative half is right here. Go up, down, left, and right all by 1. And then just draw your perfect circle. I've had a lot of practice with this, so my circles usually look pretty good, if I do say so myself. But you know, if yours is lopsided or it's like, whoa, that's a circle, that's okay. I'm not judging you on your art. All right, last example. Find the standard form of the equation of the circle. So it gives you the center and a little bit of information about something else. So it's tangent to the y-axis. So let's just go ahead and draw that. So tangent to the y-axis means it like touches the y-axis and bounces off. It doesn't actually go through it. So it's doing something like that. So it's hitting the y-axis at that point, right at 1. So from the center to the point, though, is going to be the radius. So the distance from the center to the circle, to that point, is 3, so the radius is 3. So now I have everything I need. It's x plus 3 squared plus y minus 1 squared is equal to, and take the radius, square it. So the radius is, or the number there is a 9. Okay, so that is going to do it for section 1.4. Again, sorry it's a longer video than what I typically like, but since that was it, there you go. Oh, also on example 2, I forgot, I kind of took off or didn't do the intercepts. So there you go. All right, so go ahead and give the homework a shot. Let me know if you have questions on it.